Hello, everybody. This will be a video on using the comparison tests. We have two comparison tests to use for series convergence and divergence. The test on the left is the comparison test, and the test on the right is the limit comparison test. They are very similar in how they work. The similarity is that in both of these tests, they'll require a comparing series built off of a comparing sequence. This B sub k, or series B sub k, is the comparing series. I've highlighted all of them in gray. Then the difference, back to the similarity, is that the original series in both tests, this series that you're given, the series of A sub k, or over here, the series of A sub k, its outcome, its fate, the conclude, whether it converges or diverges, it will only ever agree with the outcome of the comparing series. So if the comparing series diverges, then the original would have to diverge also. If the comparing series converges, the original would have to converge also. You can't have a original converging if the comparing series diverge. That's never an outcome. The original will always ever agree with the comparing series. The difference in these two tests is that the comparison test, you have to size up the comparing sequence with the original sequence in terms of one being greater than or less than or equal to the other. In the limit comparison test, you have to take a limit and analyze the limit. So we're going to look at two series, this one on the left and then one further down here. And in both original series, we'll use the comparison test and the limit comparison test to look at the differences. So this series from 1 to infinity, k cubed over 2k to the 4 minus 1, we need to, let's see, so a sub k is this general term, k cubed over 2k to the 4 minus 1. We need to pick a comparing sequence and then build a comparing series off of that. So for our choice in b sub k, the comparing sequence, we have to do some analysis and think, well, k cubed over 2k to the 4 minus 1 will start to behave like k cubed over 2k to the 4 for k values really big or further out in the sequence. So as to say, the -1 is going to be insignificant for a specific large k index. And then this is equal to 1 over 2 to the k. So let's use 1 over 2 to the k as our comparing sequence. Then let's notice, let's see, so then let's notice that this comparing series from 1 to infinity of 1 over 2k, this would diverge because it's a p series. P is equal to 1, and that's less than or equal to 1. All right, so then for our comparison test, we have a comparing series that diverges. That puts us in this row here, the second row, or the second row here. And I should say, back to our conditions, both of those were positive. So our A sub k sequence and B sub k sequence are positive. We have a comparing diverging series. We would be able to say that we have a comparing or a diverging original series as long as the A sub k sequence is bigger than or equal to the B sub k sequence. So the last thing to show is that A sub k is in fact bigger than B sub k. So A sub k, so let's show that A sub k is bigger than or equal to B sub k, and our A sub k was k cubed over 2k to the 4 minus 1, and that would be bigger than k cubed over 2k to the 4, and because the numerators are equal, and that denominator here is smaller than this one, so this fraction's bigger than this fraction, and our k cubed over 2k to the 4 is equal to 1 over 2k. So now we have a sub k is bigger than or equal to b sub k. And our final conclusion is that then with the comparison test, our original series from 1 to infinity of k cubed over 2k to the 4 minus 1 diverges. Its fate is the same as the comparing series because the comparing series diverged and we were able to show that the a sub k was bigger than or equal to the b sub k. Then let's move this down a little bit. And okay, then let's take that same series. Let's use, I don't know, a different color this time. So take the same series, k cubed over 2k to the 4 minus 1. And again, a sub k, we're going to use the limit comparison test this time. A sub k is bigger than 0. Let's use b sub k again as 1 over 2k bigger than 0. We have a comparing series, 1 over 2, not 2 to the k, but 1 over 2k. Still diverges through the p series, p being 1 less than or equal to 1. And then for the limit comparison test to work for you, let's see. We have a diverging comparing series. The original will diverge also, provided our limit is not equal to 0, and our limit is found by taking k going to infinity of a sub k divided by b sub k. So take your limit, k goes to infinity, a sub k divided by b sub k. A sub k is k cubed over 2k to the 4 minus 1. When we divide by b sub k, it's the same as multiplying by its reciprocal. So multiply by 2k, divide by 1. Our limit then limit k gets big, that's 2k to the 4 over 2k to the 4 minus 1. And the powers agree, so the numerator power is 4. It's the same as the power in the denominator. So our limit will be the ratio of leading coefficients, that's 2 over 2. That's equal to 1. And we need it to not be 0. Not be 0. So our limit comparison test is conclusive, and by the limit comparison test, our original, here, let's just write this, our original series diverges. All right, then let's continue on. Let's use the same tests again, comparison and limit comparison tests, but for a different series, natural log k over k cubed. This time, let's use a little different notation. This thing is your general term. It's your a sub k. It's positive. We need to pick a b sub k. And let's see. So natural log k would compare, how would it compare to k over k cubed? Because that would be 1 over k squared. And let's see, the denominators are the same here, but k is bigger than or equal to natural log k. I think for k bigger than or equal to 2. So here we have natural log k then, bigger than or equal to the 1 over k squared. And the 1 over k squared, let's call that our b sub k bigger than 0. So now we have a b sub k bigger than or equal to an a sub k, and we have our comparing, ooh, it was from 2. Our comparing series, 1 over k squared, is a converging p series. P is 2 bigger than 1. So back to our test. We have a converging comparing series, and b sub k is bigger than or equal to a sub k. So back here, we have a converging comparing series. B sub k is bigger than or equal to a sub k. We can conclude that our original converges also. By comparison test, original series converges also, just like your comparing series. Then if we use, oh, you know what, I should have used gray on all of that. Let's, well, no, I'll just switch to gray over here. Now let's use the same series again. And we'll use the limit comparison test. So there's our a sub k, it's positive. Our b sub k was 1 over k squared, it's positive. And now we need a, and our comparing series converges, p is 2, and that's bigger than 1, p series. Now we take our limit, k to infinity of natural log k over k cubed times the reciprocal of b sub k, k squared over 1. This would simplify or reduce to natural log k over k. And what do we want? Let's go back. So our limit comparison test, we have a converging comparing series. Original will follow suit as long as the limit is not infinite. And if we go back here, this limit, let's see, you can analyze this two ways, I guess. The denominator gets bigger faster than the numerator. So this limit goes to 0. You could also use L'Hopital's rule. The derivative of the denominator is 1. Derivative of natural log k is 1 over k. So we're looking at the limit k gets big of 1 over k, and that's 0, and we needed it to not be infinite. So our limit comparison test works. LCT limit comparison test says our original series converges. So both of these tests require picking a comparing sequence, building a comparing series, understanding quickly if that comparing series converges or diverges. So it's helpful to pick a converging series that is known to us, like these p series that we picked. And then you have to take a limit, or you have to analyze whether or not the comparing sequence is bigger than or less than our original. So for me, the limit comparison test is quicker and easier to take that limit than to try and compare if, say, b sub k is less than or equal to the original sequence, or the other way around. All right, y'all take care. I'll see you soon. Reach out with any questions.